Okay guys, so in this video we're going to be looking at something called topologies. Now, a topology is, we're going to look at what a topology is, and then we're going to look at the four: ring, bus, star and mesh. So topology is basically, it's a network design, or it's a network layout, and they come in two forms. You've got physical and logical. An architect or a building designer or somebody that's a network manager will want to know whereabouts the devices are located within a building, what the connections to those devices are, and they want to physically know where the devices are. So if they need to go fix something, they can look at it and say, oh, PC 1726 is broken, let's have a look down the list, whereabouts is this? Oh, on my physical topology it shows me it's part way around, class in D14, I need to go fix it, and I know exactly whereabouts I'm going. A logical topology, on the other hand, doesn't show you where things physically place, but it gives you how the networks stack logically, and it will make more sense when we start to look at the bus LAN, when we start to look at bus, ring, star and mesh topologies. They're all logical. You might say, well, what is the point of a logical topology? And the answer to that one is simply, they help you save space when designing. A physical topology, you have to have a physical plan for every single room, every single area of the building, and they can become quite large. If you imagine this is like a blueprint of your entire premises. If, for example, we were looking in one of the other videos at WANs, if, for example, you've got a supermarket, and you've got a branch in Nuneaton, you've got a branch in Birmingham, you've got a branch in Glasgow, one in Cardiff, one up in Chester, one over in Leeds. You can't physically have, and you might have like 100 branches, or you may even be a global company that have got like hundreds of offices all over the world. You can't physically map every single layout. What you need is, you need something which allows you to look at your network in a little bit more abstract way, and that's what a logical topology does. It allows you to view your network from an abstraction, if that makes any sense. Hopefully, as we start to look at the different types of topology, it will make a little bit more sense. So, the ring topology, I'm going to use my mouse. I hope you can see the mouse. If you can't, I do apologise. But each one of these green dots is what we call a node. Now, this node can be, in a ring topology, it can be a router, a switch, a hub. It can be a PC. It can be a printer. It can be any piece of network equipment. Now, in order for a node to connect to a network, it needs something called a network interface card, NIC, which we'll look at in a lot more detail in later videos. But for now, all you need to know is that they need a network interface card to connect. So this node here, this green dot, requires two network interface cards to form or be a part of a ring network. So you've got a lot more equipment involved with something like this. You need to make sure that there are two interfaces. Most modern computers only come with one interface card, network interface card. So you wouldn't be able to form a ring network with most modern devices. You would actually have to go out and buy an extra network interface card to form a ring network. Now, ring networks were really popular back in like the early years of computing, purely and simply because you could have this ring network, and all the devices on a single floor of an office block could be connected together, and they could all share the same resources, and you could share the resources of the printer, and you could do lots of really great things with it. But unfortunately, the downside is, if this connection breaks, any one of these connections, if they break, the entire network goes down. And then, as a manager, you then have to find out which connection it is that's broken, like physically going to each connection and then checking the cables to make sure that they're all broken. Because when we say a connection is broken, we don't necessarily mean somebody's cut it. You know, one of the cables inside this link could have snapped somewhere. So you can imagine having to go around and physically check every single cable. And you know, this has only got 6 nodes, but imagine if you had like 20 or 30 nodes. That could take you a good couple of hours to check every single cable. So in terms of manageability, if it fails, the ring network is not very good. Only one device can communicate at a time. Now, I've put up here, it's called a token ring. Now, each node has a theoretical token. Imagine it like a game of poker where they've got the dealer chip, and if they've got that dealer chip, then they can communicate. If they've not got the dealer chip, they can't communicate. And this chip is passed around from clockwise around the ring or anti-clockwise, or however it's set up, but it's passed around the ring, and if, you know, as the device gets that chip, if it wants to communicate, it can do. If not, it passes the ring on to the next person. And this constantly goes around. Now, when a device wants to communicate, if it's got that chip, it can send the information. Now, what it does is it sends that information clockwise around the ring, and the device who needs that information will pick it up. The rest of the devices just discard it. Now, this means that every single, say, if we start off at this sort of like 1 o'clock position here, and we wanted to communicate with the opposite side, and we send the information clockwise, it's going to go through the 3 o'clock, the 5 o'clock, and then it's eventually going to reach the 7 o'clock position. And that's 2 devices that have read the information. Now, if that's a confidential document that's being sent round, those 2 devices technically have access to that document. So with a ring network, it's a lot less secure. Only one device can communicate at any given time. However, they get the full bandwidth of that connection, so it can be a little bit quicker. This topology is largely outdated. It's very, very, very rarely seen. You wouldn't use it. Primarily because of security. The bus topology gets its name from looking like a bus network. So you've got the point at the beginning, and you've got a central backbone which travels down, and you've got different stops or different nodes that come off along the way. Once again, each node is required to have a network interface card, and if they don't have the NIC, they're not able to communicate. They're not able to connect to this network. The cable itself uses coaxial cable, and either end of this cable needs to have something called a terminator. And you'll see when we look at the media the reasons why. But if those terminators are missing, or if they get knocked off or they get lost, then the network goes down. Also, if one of these cables, be it the backbone or one of the computer cables, goes, the network goes down. It becomes unterminated, and the entire network fails. Now, once again, if information, if you know that this first PC wants to send, or this first device wants to send information to the last device, information is sent out and it goes to every single PC along the way, every single device along the way. So it's very, very insecure. Every device can see all the information that's sent across. Unlike the ring, which, as it goes round, you know, it'll see the first 2 devices and only they'll see it because the final device will pick up the information. Every single device in the bus network gets to see that information. It is high speed primarily due to the cabling that's used. It's got a thick copper core. However, once again, not really seen anymore. You used to get to the point where you could get this like a screw fitting to connect to one of these, and you could literally get a device, sneak into a building and screw into this backbone cable, and you could listen to the traffic over that network. Not very secure in any way, shape or form, and for that reason it's largely outdated. Now we come on to the star topology, and by far the most common of all topologies used. This is used heavily in local area networks. Every single home hub device that you get from your internet service provider uses a star topology. You've got one central point. It's sometimes referred to as a spoken hub, because it resembles like the spoken hub of a wheel. You've got one central device, the hub, and you've got the spokes that come off, and each node is connected to one central device. If this central device fails, everything fails in that network. There's no getting away from it. However, if this top cable is broken, only the top device loses connectivity. You reduce network traffic, and you also increase security, because if the top device, the 12 o'clock device, wants to communicate with the 5 o'clock device, it comes into here and that information is sent straight out to that device. It reduces network traffic massively. That being said, that only works if the central device is a switch. If the central device is a hub, it's a different kettle of fish, but we will look at that at a later date. All you need to know is it's generally more secure and network traffic can be reduced. As I said, this is a preferred choice of network. It is by far the most common type, and I would strongly advise being able to recreate this type of network if asked to draw it. The things that people will be looking for will be a central point, so you'll need to say that this is either a router, a hub, or a switch. You'll need to show the physical connections coming off of it, and I would label those up as connections. And for each one of these nodes, I would draw on that each one of these nodes is either a printer, a PC, a laptop, a mobile device, or something. You only need to label one of them up as a computer or a server or a printer. Central point is a router, hub, or switch. Outside devices are printers, servers, or computers. Lines are the connections, and if you wanted to get fancy, you could even put a little line here and say that they need a network interface card, because each one will need a network interface card. Another downside to this is these routers, hubs and switches can be quite expensive, so this network cost is a lot greater than like the bus and the ring network. The final one that we're going to look at is the mesh. Now the mesh is a little bit of a hodgepodge of all the other different networks. So in here you'll see that we've kind of got a ring. At the same time we've kind of got a bit of a star thing going on here. And we've also got a bit of a bus thing going on here as well. So it's a little bit of a hodgepodge of different networks, and it's a little bit of a mix-up. And no two mesh topologies will generally be the same. If it doesn't fit into any one specific category, it's a mesh topology. That's what you need to know. Technically, you'll see hybrids and you'll also see fully connected, but for this we just need to know for rings, bus, star and mesh. In terms of the characteristics of this network, you're going to need to look back at the characteristics of the other network. This will have a greater degree of redundancy, because if this central link from the top node across to the bottom node fails, well, you've still got a connection that will come down the side here and you can still pass information through. However, bear in mind that information is not secure. The star network, as I mentioned, is typically used for LANs, local area networks, homes, offices, schools, and that'd be like each classroom will be connected up to a central point, and you might even see a star network of star networks. So each classroom has a star network. Those are all connected together in a star network fashion. The mesh topology tends to be used in terms of a wide area network. So this would typically be a local area network or a metropolitan area network. This would be a local or metropolitan area network. That would be a local area metropolitan. And each one of these nodes will be a local or metropolitan area network, and they would have some backbone connections between them. Usually these are high speed connections, fiber optic connections, super fast connections. And you tend to see this sort of diagram. So this would be like Asda Nuneaton, Asda Birmingham, Asda Leeds, Asda Scotland, Asda, wherever, Cardiff and Chester. And they would have links between them, individual links between them, like straight links. And that kind of covers what we're going to look at with regards to topologies.